Hello and welcome to General Chemistry 1. My name is Dr. Gina Little and I'm delighted to be your professor this semester. You're going to find out this semester that I'm very passionate about chemistry. One of the reasons I love chemistry is that at its heart, it explains how very complex interactions that are necessary for our world are really come down to the basis of interaction between just one or two atoms. For instance, DNA replication and restriction enzymes involved in that really have the atoms have to recognize one another to know exactly where to attach to the DNA strand to be able to break it apart. This is just amazing to me that such tiny interactions can happen millions of times per second with very little inaccuracies. Another example why I love teaching chemistry is it's very practical. There is so much everyday chemistry in our lives. Just for instance, chemistry is how I figured out how to cheaply and efficiently descale my coffee maker for a lot less by figuring out what are the critical food safe components that I could make a solution of and how much of what I need to be at the right concentration. You might be nervous about taking chemistry. A lot of students are at this point. I often find that students enter a little bit nervous, not sure what they're going to encounter. I just want to assure you that you are not alone. As you can see from a recent survey, and this survey I do each semester, and it's about the same responses, is that for about most of the students are either excited or tense. They're kind of in the middle. They're a little bit nervous, but they're also a little bit excited. The proportion changes, but even if you are terrified of chemistry or you are so delighted to be here and excited, you're still probably in 10%, and 10% in a class this size means you are not alone. So you are on this journey together with lots of other people. So what are you going to get out of gaining chemistry? I frequently hear from students, very few students in this course are going to be chemistry majors, and I frequently hear students saying, I don't know where I'm going to ever use this in real life. And maybe you won't need to know the molar mass of phosphoric acid in real life. However, employers consistently are ranking soft skills above GPAs. So simply using AI to get the answers or to cheat on a test is not useful because you're not going to be getting the value out of it. What is valuable about a degree is not just the GPA. It's about all of these soft skills. For instance, teamwork and interpersonal skills and research experience are ranked significantly higher above GPA by employers in the chemistry field. Specifically, they're looking at things like can you communicate with other people and work with other people in teams? Do you have a strong work ethic? Do you have problem-solving skills? Your initiative, your perseverance, your resiliency, those are really critical skills, and you will definitely get them tested and built up in this semester. Analytical and quantitative skills is one of the strongest features you're going to learn in this class. So this is going to be helping you prepare for the real world and gain skills that employers are looking for. So let's talk about one barrier in chemistry. I think that one reason, there are several reasons, but one reason students struggle in General Chemistry 1 is that the types of questions we're going to ask you are structured differently. So the learning objectives in this course are primarily higher level thinking skills on the Bloom taxonomy. So instead of asking you just to remember something or to explain what it means, we're going to ask you to apply concepts, to analyze material and data given in a question or a problem setting, maybe to evaluate certain things. And these tasks are a little bit trickier. So let me explain an example of a difference between the lower order remember and understand questions, which you may be used to from other courses, and what an application question might look like. So for instance, on the remember and understand, I might ask you, what are the 4 quantum numbers? Now, again, this would be content we're going to cover this semester, but you will learn content that the 4 quantum numbers are N, L, ML, and MS. You will also learn rules about what their allowed values can be, that L can be from 0 to N minus 1, and ML can be from negative L to positive L. I might even ask you something like, what are the possible values for quantum numbers L if n equals 2, where you apply the rules, but in a fairly simple way. However, this would be a true analyze and application question. How many electrons in an atom can have n equals 3 and ms equals plus 1/2? So I have to analyze and recognize that this is using quantum numbers and that it only gave me 2 of the 4 quantum numbers. And specifically that because of those, I need to determine what are the possible values of the other 2. But since they're dependent on each other, I first have to figure out the allowed values of L, and then for each allowed value of L, I have to figure out the allowed values of ML, and I have to combine them in a set of sets. And then once I've done listing all of my sets, I need to count them and come up with an answer. This is an example of an application question, and you can see it's much more intense than simply a, hey, just spit back some answers or maybe understand them. It's a higher order thinking skill, but you're gaining those higher order thinking skills that are so critically valuable in the real world. So how can you be successful at this class? So there are things you can do. One is you're going to have to be active in this course. Expect to take 9 to 12 hours a week studying chemistry. It is helpful if you prepare before the lectures. So pre-expose yourself to the material. Even reading the textbook, reading the notes, even if it doesn't fully make sense, still helps you get exposed to the vocabulary words. Looking at the questions on the homework problems, and even if you don't know how to solve them, but seeing them, getting exposed to what might be asked and seeing the examples of what I might want from you. And then during the lectures, participate and practice. So pause the video and try problems. Review the worked problems that I show. Practice the homework problems and try doing it without help. Before you get help, try struggling and just trying to say, like, from my notes alone, can I do this homework problem? If you can't do it, then get help. But then practice some more once you've learned that. So go to the end of the chapter and get more questions. Find other questions on the internet that are from reputable sources. Study with others. Attend office hours. Again, that teamwork and collaborative is one of the important skills that we learn as scientists. And then try something called spaced review. We know that the brain absorbs material, and if we give it a spacing to sort of absorb it, and then we repeat it, and we do that frequently, that spaced repetition really helps with storing the material in long-term memory so that it's accessible when you need to apply those concepts. You have them stored in long-term memory. So frequent review of your vocabulary and concepts learned. You know, you can have flashcards of the vocabulary words and just go through them. Takes, maybe 2 minutes a day to go through that week's vocabulary words. You do that several times during the week, you've probably learned them. Try reorganizing the material. Rewrite your notes, make concept maps. Try something called Cornell notes, where you take the notes and then you have a summary of the notes on the side, and then at the bottom you annotate it. You can do chapter outlines, study guides, visual organizers. There's a variety of methods, but the more you interact with this material, the better you're going to get at it. I'm looking forward to a great semester.